In this video, we're going to be talking about CIP mode. So what is it, how we use it, how frequently I should use it, those kind of things. And then most importantly, we're going to be talking about how do you know what your CIP set point should be. So the CIP mode is our way of allowing you to harness the disinfecting power of ozone to clean other parts of your system. During CIP mode, we would be using highly ozonated water that has more ozone content than normal operation. And you can use that to sanitize anywhere that water goes. That could be your fertigation equipment, your batch tanks. If you have the plumbing that will allow it, your distal irrigation plumbing, drippers, if you're growing in baths, anything like that. So again, that's what CIP mode is. Again, ozone's a really powerful disinfectant. And so we can use that to clean not just the water here at the system, but other parts of your facility as well, provided you have the right plumbing set up. And we'll talk about that. CIP mode is indicated here. Page 1, the main page 1 control screen. You can touch right there. You can adjust your set point. This is different than the regular set point, which we've covered in another video. But you can also go to main page 2, and you can manually start and stop CIP mode there by pushing either sanitization on or off. Just by way of reminder, we've talked about this elsewhere, but during CIP mode, the ozone production gets ramped up. And we also open the actuated valve on the filter bypass manifold so that we bypass the filter and are able to keep more active ozone into solution. So in determining CIP set point, really all of the same rules, or at least most of the same rules, apply as in the video that we made regarding what is my normal set point, which is what the system is going to be in the vast majority of the time. So having said that, the same principle applies in that we have to test at the point furthest away from the system, wherever that is that you want to disinfect. Typically that's in a distribution line right by a dripper or something like that close to the plant. We need to know what that ORP level is in line and then either adjust up or down at the system. So we test and then adjust. Now, this is a little bit different than what we explained in the other video. For CIP mode, it's important that we know what the ORP level is in line under pressure. And the reason is that as soon as this water comes out of pressure, either in a holding tank, out of dripper, whatever it is in a batch tank, the ORP level is going to be cut in half. That's also why we said in another place that it's fairly difficult to deliver enough active ozone in most applications to harm the plant. It's because the ORP is getting cut at least in half as soon as it depressurizes. But remember, for the purposes of CIP, we're trying to clean inside the line, so we don't care what the ORP is as it comes out the dripper. Not for CIP mode. We do for regular operation and keeping the plant safe, but for CIP mode, we need to know what it is in line under pressure. And so we build a panel that you can see there, this little yellow ORP probe, and it's designed to be mobile. So what we recommend is that you build a manifold. If you don't want to do this in every grow room, do it at least in the one that's furthest away from the system. Usually put a ball valve in a ball valve so that we can isolate and not make a mess. Then you have a union and a union so you can take it out at any time if you ever should need to. And then in the middle, there'll be a T with 1/2-inch thread. That ORP is a 1/2-inch thread probe. So the way it's designed to work is if you want to check the ORP level in that line, isolate it, take the plug out, stick the probe in, open the lines again, run water through there, and the panel will tell you what the ORP level is in there. When you want to take it out, you should do everything in reverse. Close your ball valves, take the probe out, put the plug back in, open your ball valves. You can take the panel elsewhere if you want to. If you would like us to build you one so that you can just have one stationary in every room, we can do that as well. But the main point is you need to know what the ORP level is under pressure for CIP mode set point determination. Just reading with like a little handheld meter coming out of a dripper per se is not going to tell you what the ORP level is in line under pressure. So that can't be stressed enough. So generally we recommend that you be at 600 or maybe a little over to make sure that you're getting full disinfection and sanitization inside that line. Now, there's a couple qualifying things that you need to consider. This would be with the assumption that your line is relatively clean or completely clean of biofilm. So if you've just flushed or if it's a new pipe installation, whatever, 600 may be enough, but if you already know that you have some growth in there, especially if it's significant, 600 may not be enough for you to clean those lines out. This is again why it's important that we're testing and then we're adjusting, because depending on the levels of growth that's happening in those distal lines, your ORP levels could vary pretty dramatically from, say, this week to, say, 2 weeks from now, or maybe even just a week. So again, we have to make sure that we're getting at least 600 More is not necessarily better, but at least 600. And again, if you're not measuring inside that line, then you have no idea what it needs to be adjusted to at the system. After you've determined what your set point is, there are still a couple other things that you want to consider when using CIP mode. One of those things is people want to know, well, how frequently do I run this? How many times a day? How many times a week? Whatever it is. The length of the cycle, all those kind of things. And so what we can do is give you some general recommendations. This can be used in a variety of different ways to fit within your process. So there is some testing and determination that needs to be done on your part. But with these principles, this will allow you to do this fairly easily. The next thing is we need to figure out how frequently you're going to run this. Now again, some people do this once a week, some people are a couple days a week. What we recommend for most applications is that you run your CIP cycle once a day and you make it the last irrigation event of the day. So a lot of people will just make it a whole separate irrigation event and they'll do it as a clear feed. So in other words, there won't be any nutrients in the water and they just send that water to their plants. But more about that in just a second. By doing the CIP cycle as the last event of the day, what you're doing is making sure that you're not just leaving a whole bunch of highly oxygenated water sitting in those lines overnight, because that is the very environment that's going to grow biofilm. So by sending that highly ozonated water with most of that oxygen still being in the form of ozone, then what's going to happen is you're going to effectively kill everything in that line, and then that water can sit in there overnight, and it's going to be way less problematic than, again, if you leave just oxygen sitting in that line overnight. So again, we recommend that you do it as the last event of the day. If you have questions about that, you can give us a call. We'll help you try to figure that out. But again, that's a good general starting place or thing to consider. Another couple of things that you want to consider when determining this process and working the details out is nutrients. So if you're using organic nutrients, that's going to tend to fuel biofilm growth quicker than if you're using inorganic commercial salts. And so again, you're typically going to want to run CIP a little more frequently, maybe a little bit longer too. So that'll be one consideration. Ultimately, no matter what kind of process you settle in on there, the last thing you have to figure out is what do you want to do with this water that's in the line? So you can do two things. Obviously, that water, after it goes through and it's used to sanitize, you can either dump it, or we recommend that you use it as a clear feed if you're not doing that already. So a clear feed would just be irrigating the plants with water, in this case, highly ozonated water, or highly oxygenated water, rather, but it doesn't have nutrients in it. So again, you would make this a separate irrigation event for the end of the day, and it wouldn't have nutrients in it. Now, there's a couple of considerations there as well. The first thing you should know is, one, by doing this, this will benefit the health of your plants. By irrigating periodically with non-nutrient water, this helps to prevent salt buildup on the roots, and this is going to be even more true because of the high oxygen content that it has in the water. So if you decide to use these clear feeds instead of just dumping the water as in a flush, the next thing you have to consider is, do I want this water to go through my fertigation system but just not add nutrients? So in other words, if you're going to make this a separate irrigation event, you have to decide, is it acceptable to just send it out, say maybe bypassing your fertigation, or do you at least want it to go through the metering part of your fertigation so that you can keep track of that water that went to the plants? So that's something that you'll need to decide, whether you just bypass fertigation totally or whether you send it through at least the metering. A couple of additional considerations when using CIP mode. As we've already discussed, your ORP level is going to decrease pretty significantly once that water is not pressurized anymore. So let's look at an application where maybe you're using batch tanks, okay? In this kind of scenario, your fertigation equipment and your batch tanks are going to be seeing enough active ozone that they're going to stay clean. So again, if you use this technology and you run your ORP levels appropriately, you're never going to have to scrub out a batch tank. But having said that, the water is also depressurized in that situation. So if you're also wanting to sanitize the distal part of your irrigation plumbing, so in other words, the lines that are connecting your batch tank ultimately to the plants, then we've got a problem. Those lines are going to contain plenty of active dissolved oxygen, because oxygen is going to be much more stable in the water than ozone is, whether it's under pressure or not. So the problem is not going to be getting oxygen to your plants. The problem is going to be, again, if you want to use CIP mode to sanitize those lines. And so what we have people do in this case is sometimes you have to work with your fertigation supplier. Sometimes you can just simply install a manual bypass around your batch tank that you can operate once in a while just for CIP mode. But however you do it, you've got to be able to keep that water under pressure and then be able to deliver it wherever you want to use it to sanitize. So typically, that's going to involve bypassing your batch tanks. And again, that could be a manual bypass. You could set that up to be automated. You might have to work with your fertigation supplier on that. But again, you need to be able to keep that water under pressure to keep high levels of active ozone in there. The same setup would apply for anything else. Batch tanks are the most typical scenario, but anywhere that water might depressurize, you're going to want to have to account for that if you want to sanitize after that. So ultimately, when we're talking about CIP mode, again, just to recap, we need to find out what our set point needs to be. You have to do that by testing and then adjusting. And then we also have to work out this process. And there are things like frequency, duration, and then what do I want to use that water for? Do I want to dump it as a flush, or do I want to use it as a clear feed? And then the considerations that come along, possibly with metering in your fertigation unit. But ultimately, we've designed this process so that you can keep your entire system, not just what you see here, but other parts of your water treatment process free of biofilm growth.